Let's go over the pre-lab questions. Number 1, what is solubility? Let's keep it simple. I'm going to say that it is the ability of a solute to dissolve in a solvent. Number 2, what two conditions are necessary for successful collisions between water molecules and potassium nitrate? So I'm going to talk about this a little bit before writing out an answer. Molecules must collide with high energy so that the chemical bonds can break. So that's what we saw in the video or the PhET simulation last week, where the collisions of those water molecules broke apart the sodium chloride. Sodium ions were surrounded by water, and then the chloride ions were surrounded by water as well. Molecules must collide with proper orientation, as in positive are attracted to negative charges, or negative charges attracted to positive. Remember, opposites attract, y'all. And then the same charges, negative, negative, positive, positive, they repel each other. So they must collide with proper orientation of attracting each other. So positive with negative or negative with positive. So let's write that down, y'all. Molecules must collide with high energy to break those bonds and in proper orientation. So we're going to see that demonstrated in number 4. So number 3, it says write the dissociation reaction for potassium nitrate. So let's go ahead and do that. We have potassium nitrate, KNO3. When put in water, dissociates to potassium ion and the nitrate ion. Number 4, draw the molecule to ion attractions that are formed when potassium nitrate is added to water. So, the potassium ion would be surrounded by water molecules with the oxygen side facing it. Okay, while the nitrate, which has a -1 charge, would be attracted by the positive side of water. So that's what I'm drawing here. Be sure to note the hydrogen side is the one with the 2 circles, or the Mickey Mouse ears as I like to call them. And then the oxygen side is the side with the ears pointing away. Okay? So number 5, describe how temperature affects solubility of ionic compounds. So hopefully you guys copied this down from the bell ringer, and if not, here we go. As temperature increases, the solubility of ionic compounds in water increases. For this experiment, what is the solute and what is the solvent? So the solute is potassium nitrate, and then our solvent is water. We're dissolving it in water. Number 7, what does the recrystallization of a dissolved ionic solid indicate? So, the recrystallization of a dissolved ionic solid indicates that the solution is currently saturated at the current temperature. And that the solvent cannot dissolve any more solute. Okay. Number 8, we're going to define these three solutions, y'all. A saturated solution is a solution that has dissolved. The maximum amount of solute. Meaning, if I were to add any more solute into a saturated solution, the solvent would not dissolve those solute. So, for a graph, y'all, if I were to graph this, if this is my line, any point along this line is considered to be saturated. For unsaturated, is defined as a solution that can dissolve more solute. So, is able to dissolve more solute. So, if this was my solubility curve, again, any point below this line, y'all, the area I'm shading is considered to be unsaturated. And then supersaturated is a solution that has dissolved excess solute because it has been heated. So, has dissolved excess solute at a higher temperature. So if this is my solubility curve again, any point above this line or curve is considered to be supersaturated. So what happens with a supersaturated solution, y'all? Well, when it is cooled, solid crystals will form because it has reached a lower temperature where the solution is already saturated, but we added excess salt, and that solute can no longer be dissolved in that solvent. Okay, y'all. Watch the video below for the lab procedure where you guys will collect and observe what is happening in the lab.